Thank you everybody for coming. This is JSL webinar for document visual question answering. Um, my name is Alberto. I am the lead of the visual NLP team at Jon Snow Labs. Today I'm going to be presenting to you what I hope is going to be a really interesting talk about document visual question answering. First, we're gonna be discussing briefly about the visual question answering task. In particular, the flavor that we're dealing with today, that is, applied to documents. The title of the talk is Zero Shot Document Visual Question Answer. So we're gonna explain a bit what Zero Shot is all about. We're gonna really briefly touch on some common architectures for dealing with this problem. Then we're gonna discuss some practical considerations when you want to build a real world pipeline in which you actually want to solve problems by using this technique. We're gonna see an example on document classification, invoice processing, and then another one on table detection, right? In which we're going to be applying, visual question answering to tables and to invoices, respectively, right? Then I'm going to explain a bit what the roadmap of JSL is on visual question answering. And at the end of the talk, we're going to take some time to answer questions, okay? Okay. To explain the task itself of document visual question answering, is not basically you can compare it with the question answering task in natural language processing, and you can say that it is not the same, because you actually need to make sense of visual clues that are found in the document. Basically, everything that is going to provide additional information, understanding of a graph, for example, or a chart or a table, whatever visual clue you have in the document that is going to help you make sense of the information to answer the question, you need to consider all that, right? The particular version that we have here, we say that it's an extractive task, meaning that whatever the model is going to return as an answer is going to come from the text itself that is present in the document, right? So you cannot do anything like tell me the number of times that you have that a country is mentioned in the document. You cannot do that if that's not explicitly mentioned in the document, okay? So it's going to involve multi-step reasoning, and an example of that is when you have to make sense of a graph. So you first need to understand the indications and the notes on how to read the graph. Then you have to go to the graph on a second step and actually extract the information that the question relates to. Okay. So yeah, this involves a mix of computer vision and natural language processing, right? You need to actually make sense of the image. You need to process the question itself, right? So you're able to relate it, to the image and actually come up with an answer. So you can apply this to other tasks, in visual document understanding, and you can try to formulate them as a question answering problem. For example, when you're extracting key values or when you're doing table processing, right? You can actually apply visual question answering to help you deal with these problems, okay? So the interesting part is, the zero shot, the zero shot part. And basically, the idea behind zero shot is that you're gonna have a model, and you're gonna ask for things to the model, or try to have the model, for example, to reason about things that it hasn't seen explicitly during training. So, for example, in a classification problem, you may want the model to return labels that the model hasn't been trained on, during the training phase, right? And yeah, that's basically the idea. And I actually want to give you a quick example so you can build some intuition around this. It's like the message I want to communicate is that this is not magic. I mean, there's actually a way that you can think about this in which, you know, it's going to make sense to you. Hopefully, after this, you're not going to be like afraid of using it, right? So suppose that you have a model here at the top. You have this model for doing object detection. So you basically um, have you input, to the left, you have your input, the input to your model, and you train this model with labels such as, gray duck, red bird, white cat, and you expect the model to be able to locate those objects, right, on input images, right? So if you remember the properties of your word embeddings, whatever version you have, but suppose that you have the most basic, version, some word to vec, some globe, something really simple. So you already have the intuition that the embedding for pigeon, right, is going to be, geometrically close to the embedding for bear, right? So even being the case that white pigeon, has never been input to the model during training, the model is going to be able to extrapolate, to what a white pigeon is, because it really knows about birds and it really knows about white stuff, right? Because it has been exposed to that, during training. Okay, so when you have something like white pigeon, and gray dog, for example, right? So the model is able to identify what a dog is, sorry, what a cat is, because it was trained with that label, at the training stage. So more or less, the embeddings for cat and dog are similar because they are mentioned in the same context, and also when it comes to visual clues, the cat and the dog, they appear at the same region on images. They are typically surrounded by the same things, and they share a number of lower level features, like hair and stuff like that. So there's like a possibility of the model, being able to return the picture of a gray dog, actually. Okay, the region for that. That's just to build an intuition and to make sure that this is not magic to most people, right? So now we jump right into the problem, and for doing that, we have an example here to the right. Here we have 3 questions, and so the first is the top. What is the issue at the top of the pyramid, right? Um, so retailer calls and other issues. So if you think about it, um, in order to be able to answer these, you need to you need to understand that there's a pyramid on the picture and that you have a top part of that pyramid, right? So when they ask about which is the most critical issue for live representative support, right? So that is corresponds to this text here at the bottom. You need to make sense of this arrow. Okay, you need to make sense that when you go up in the pyramid, things become less critical, right, than when you are at the bottom, right? So the visual clues are important. That's the message, right? And yeah, here I think this is a definition, an interesting definition. I think from one of the papers of dataset for this task. And yeah, it includes many more things. And so here we have another example, and I don't want to take much time because we have some real world examples, with notebooks and code. So But yeah, if you take a look here, for example, the first one, what is the acceptable hemoglobin level, right? You have like 4 columns: deficient, low, acceptable, high. You need to make, you have to, you need to make sense of this table. You need to make sense, that things are organized in rows and columns, and basically you need to relate this title here, for the row with this title here for the column, and you need to return this value here that is 14.0, 14.9. Okay, and the same, with the others. And then you have some other variations, right? For example, what is the number circle here, right? 098 with a unit. And you can have, many different flavors of this same problem. Okay. So now we're going to be touching really briefly on what the architectures, or the most important architectures for dealing with this problem are. It's going to be really brief because we may need like an entire day, for discussing this in detail. There are many different people and teams working on this, and this is really an active area of research. So basically, you have two types. It's like you can have an OCR plus a decoder, and when I say decoder, it's a language model, and then you can have encoder and decoder, right? And when I say encoder and decoder, is a visual transformer encoder with a decoder, that is a language model. The things, or the axis over which this can be classified, is are first the pre-training objectives. They pre-train on different objectives. When they do the pre-training, they follow the well-known recipe in industry of pre-training over a general data set and fine-tuning on downstream tasks. Then another thing that's going to change is the attention type that they use, and some of them propose even processing the things in the page on different orders. They claim that they have advantages by switching between different types of orders. And yeah, basically the OCR plus decoder architectures, they use 3 types of features in general. They use the layout, meaning that they use the position. They use the text that is coming from the OCR, and they use the image itself. So that means that they're going to be taking patches, from the image and feed that to the model for the model to reason and extract features from it. And then the encoder decoder is like, in my opinion, is a cleaner and more simplified architecture in which they just encode all the visual clues using a visual transformer, and then they just decode. Okay, so we're going to see like 2 of these architectures. This is like the first, or at least one of the first, layout LM, in which they add a 2D position embeddings that you can see here. At this part, you can see position embedding XO, position embedding YO, X1, and Y1. That's just a bounding box, and they for the text that they have, that they are processing at the time, and they feed that to the model, right? And up here you have the image embedding that are actually in this situation coming from a fast RCNN model. And then when you put all that together, you go to downstream tasks, and basically visual question answering is one of them, because they do more things. They do document classification and other things. But yeah, this is a really popular type of architecture that is widely used these days. And this is the flavor that uses the OCR. Here, the text embedding is the text coming from the OCR. It's produced by the text coming from the OCR, okay? Then we have a different, an instance of the second type of architecture that we wanted to mention, This is an encoder decoder. And these architectures are called OCR-free, and you may guess why. You don't do any explicit OCR, you just encode the visual features, and that's it. That's all you do. So the swing transformer. This is the diagram for the donut, right? So they use a swing transformer as the visual encoder, and then they decode, using BART as the language model, right? So the way this works is that you feed the image right to the encoder, and you feed a question right to the decoder, and you start to decode, right? You start to decode, and at some point, if you provide the right tags, you're gonna have your answer, as a result of that very same decoding that took your question at the beginning, right? It's the two things, the feeding of the question and the return of the answer happen at the same time. Basically, that's the idea. Okay. Well, now we're gonna check on some practical considerations for actually building real life pipelines. So creating the questions is difficult, right? So in this example, you have like, for example, mention the zip code that is written, on the envelope. So you already know that there's a zip code there, that because you have an envelope. I mean, there's a lot of knowledge that the person already has, when they created the question itself, right? It's not trivial, okay? So if you wanted to apply this technique to millions and millions of pages, you need to somehow first screen the documents, so you can actually apply these questions to a more reduced selected number of pages, basically. Okay, that's the idea. Yeah, apply a limited, well-defined questions covering the information you need. Something that is useful is to rephrase the questions. So we're going to see in the example for invoices, you can ask, for example, what is the total amount for the invoice, or what is the amount that was invoiced, or what is the amount that was billed. And believe it or not, you get different answers, and sometimes you can just get the right answer by switching the question, from one version to the other. So that's a super interesting detail, to consider. And for materializing these ideas, I'm going to be showing some examples in notebooks, using some models from the Visual NLP library that we have at Johnson Lab. So I just have this diagram here because I want you, to have an idea. I'm going to touch really briefly on this. The Visual NLP, also known as Spark OCR product, is a visual document understanding library that runs on Apache Spark, meaning that it uses, the distributed capabilities of Apache Spark. The main abstraction there is the data frame. Basically, it's like a SQL table that is distributed across different nodes. And on top of that, we have some image preprocessing, data ingestion, and just the basics to get the images out of the documents and to perform some preprocessing like skew correction, image denoising. Then we have text detection and recognition, finding the text on your image, converting the images into digital text. And then we have table detection and recognition. We're going to be using table detection in one of the pipelines. Then we have visual document classification. We're also going to be using that. And of course, here to the right, we have document visual question answering. We are going to be using that as well. We're going to be showing some pre-trained models from the Models Hub. That is the collection of models that we make available, to users of the library. Okay, that was a super brief introduction. For this, I have two links here for the two examples that I want to show. And also, as a special gift to this to attendees for this webinar, we have a license for 10 days that you can access just by clicking here at the link. So you can access the license there, and you can run the notebooks yourself. Basically, that's the main idea. Okay, so I have like a couple more minutes, so I'm going to show you. I'm going to be running. You can run this on Colab. I'm going to be running on Databricks because it's super fast, and because I want to actually um, process, large amounts of data. In this situation, I'm processing about 40K. Okay, but let's start with this example. This one is for doing question answering on tables. And for this example, what I'm using is a type of report, that companies are required to fill, when some of the, when the CTO or the CEO, important people at the company, when they acquire or sell stock, right, of the company. The idea is that if you monitor, that type of activity, you're going to be able to tell, the direction of the company, where it's going, right, where the stock is going. This is just an oversimplified example. One of the key advantages of these documents is that they are available, and they don't contain any private information, so we can use them, for this type of examples. And yeah, for example, you have one here, and they come with these tables, and these tables show, the number of acquired units of stock, the price they pay for a unit, of course, the name of the person, right? David, Anthony, Brian. This is a company from Australia, actually, and they have this really nice website in which they make everything publicly available. So it's really convenient for a tutorial. Yeah, so what we're doing here is I'm just loading the documents. I have them on the storage on Databricks. I have placed them before this meeting there, right? So I'm just using 4 of these documents. And well, I'm just going to jump directly into what the pipeline looks like. So we have like the PDF to image transformer that is just going to take all the images, in the PDF, all the pages in the PDF, and convert them to images. We have the image table detector. This one is going to identify the regions in which we have tables, right? So we're going to leave all the rest of the document, all the rest of the page out, because we don't care about that. Image draw region is not very important, but we're using this one here in order to show the tables. I want to show, the tables. Yes, I think this is. Give me a second. For some reason, okay. So if you take a look here, I just ran this, but if you see the red lines here, these are, the tables that were detected by the model. And here, I think you're going to have to do this at home, but there's a confidence score there. If you see at the top left corner, there's a confidence score for the table detection. But okay. And here's all the information we need. So this is what the questions look like. So I'm just asking what the number of acquired units is, what is the number of disposed unit, when they sell, what is the value per unit of the transaction. And then I'm going to feed those questions to the visual question answering model here. And if you pay close attention, you're going to see the pre-train call, and that means that we're taking one pre-trained model from the Models Hub, and here we are feeding the questions. And yeah, what follows here is just a brief analysis. I'm just listing all the tables that were found across the four documents, right, with the dimensions, for the table. So this is not relevant. You can take a look after the webinar if you want. It's just informative. What we have here is, the result of all the questions applied to all the images across all the documents, right? And yeah, you're going to see that for some tables that don't have the information we need, you have like irrelevant stuff, right? Number of acquired units, and you get a date. You can filter that out. But for some others, you're going to see that the values do make sense, right? So a person bought 2,727 units of stock. They didn't sell anything, and they pay this price, right? So basically, that's how it works, and you're gonna have like similar, questions and answers from the other documents. In order to filter, the others out, you can use some rules, right? Like checking if you don't get numbers or you don't get a dollar sign like here, right? If you get text, you can just remove them, or you can also use confidence scores, right? Which at this point we are not returning them, but on next release we're gonna add them. But you can use, the confidence scores, and you can actually use that, to help you filter the values that you actually care about. Okay, so I think I have a few more minutes. So I have another example that is related to invoices. I'm not going to be able to run any of this, but here it takes just a couple of seconds, but we are like really tight on time. Here we have like a similar pipeline, but this time we are using invoices, right? And we want to extract the total amount that was invoiced in the document, right? So this is a classical problem, in a company when you have a pile of invoices and you want to see how much money is all that taking from you, right? So for you to have an idea, this is what the documents look like. We have, these are coming from the RBLCD dataset. That is a 40K dataset containing many different categories, but I'm just taking, the invoices. I'm applying a document classifier to keep the invoices. I'm going to show that soon in the pipeline, but this is, what the documents look like. At some place in the document, they contain an amount, that is the total amount that was billed to the customer, right? 2,683, Yes, this is what the pipeline looks like. This time we are starting with images, right? Because the dataset comes with images, not PDF. So we do binary to image, and we convert, the file into an image. Then we do visual document classifier. Again, we are using a pre-trained model from Visual NLP Models Hub. We build our pipeline here, right? And what I'm doing here, which you can do yourself, I'm just sampling, from those 40K documents, and I'm, doing a random sampling, and then just, keeping 5 documents just so we don't make, the whole notebook explode for memory reasons. Yeah, once you have your documents and you know that they're, of the right class of invoice, out of the 16 classes that you have, in the data set, you can start thinking about your questions, and I came up with three questions. What is the total amount invoice to the in the document? What is the amount billed in the document? And what is the dollar amount mentioned in the document? That one is a more general, and you're going to check that the results are, not that good. That one, we define the visual question answering in pretty much the same way as we did before. Yeah, we applied here on the selected invoices, on this data frame, and then we ran some simple SQL just to show the answers and the path of the document. Okay, so we can check for the correctness of some of these. So if you see here that you have 2,683, we can go back to that document. We can check the number, right? And you can see that the number matches. And you can actually, run this again, sample for some other 5 documents and run, the classification again. It's kind of addictive to do this. It's really nice. It works really well. But something you're going to notice is that when the documents are rotated, when they are rotated, 90 degrees, like this one, the results are not good, right? There are things you can do, even with, with the visual NLP library. You can correct for this. You can just, normalize it and have it, on the right direction, and the results are going to be good. I'm not doing this for this demo, okay? But yeah. You can just, continue 2,400. You can continue to play with this and try to see. Yeah, there you go. You have the number there, and yeah, you can continue to play with this and check, the right amounts come out, from the pipeline. And okay, I think this was covered in record time. I think I'm going to go back to the presentation. Okay, this is what we have covered. We have explained, the document visual question answering task itself. We have seen, some common architectures that are popular these days to solve this problem. We have also discussed some practical considerations, on how to solve them, in the two notebooks that we have just discussed. And I hope that you're going to be able to run this yourselves. Yes. Yeah. Here. Here there's the link for the license that you can just click here, and you can. I think you can directly run this on Colab. This you can come here to this. To the same repo in which the slides are located. You can just come here, open the notebook, click here on the button, open in Colab, and you are just redirected there. And you can follow the steps here, and you're going to be asked to upload the file, the license file, and you can just run everything the same way I just did. Okay. Okay. So regarding next steps, at JSL, what we are currently working on, new specialized models, meaning that models trained on for specific use cases, like chart understanding, some genetic testing, we have many things in mind. As you may have noticed that the model that I explained, it doesn't have, if you were paying attention, it didn't have any specific OCR piece, in the pipeline. That means that it's not OCR based, it's OCR free. So we may consider adding, some models that actually use OCR. Of course, continue to improve the accuracy of the models. We are taking metrics all the time. Every change we make to the model, we take metrics. Continue to improve the performance and memory consumption. These models these days, are pretty expensive to run. The examples that I have shown you are on Databricks and only CPU, and they run, decently well. They just take a number of seconds. but yeah, there's always, there's always something to be done regarding memory consumption and performance. Then we have a product that is called the NLP Lab. That is a product that we distribute for free. So what we do with models from Visual NLP, we typically use the Visual NLP Lab for integration, meaning that you can go there and do all the training, all the data preparation itself. You can do it there, and at the end you just download the model and you can use it, on your own system. And yeah, also if you have problems with the license, or happen to be trying to run these things, a couple of weeks after the webinar, you can always contact Enes or myself. This is the email from Enes, and mine is pretty similar. It's Alberto at Jon Snow Labs, so it's really easy to reach me. And well, I think we can have some time for questions and answers now.